Now let us talk about y is equal to tan inverse of x. Look at this, dear students, the graph of y is equal to tan inverse of x. Before drawing that, you should know this, right? There are two asymptotes to this graph, right? What are those two asymptotes? This is pi by 2 and minus pi by 2. Y is equal to minus pi by 2, sorry, x is equal to minus pi by 2 and x is equal to plus pi by 2 are the asymptotes. Y is equal to pi by 2 and y is equal to minus pi by 2. The line parallel to x-axis are asymptotes. Therefore, what we can say is tan inverse of infinity plus infinity is equal to pi by 2. Tan inverse of minus infinity is minus pi by 2. Actually, we should write not defined, but by looking at the graph, we can use these two words, of course, under restrictions. If you observe carefully, the graph exists from minus infinity up to plus infinity. Therefore, it is continuous for all x which belongs to set of real numbers. And of course, it is differentiable for all x which belongs to set of real numbers. Whereas, domain of the definition of the function is set of real numbers. Directly, we can say x belongs to set of real numbers from minus infinity to plus infinity. But it ranges from minus pi by 2 to plus pi by 2. The question arises whether should I write open bracket or close bracket. So, y belongs to open bracket minus pi by 2 to open bracket plus pi by 2. The reason is it ranges from minus pi by 2 to plus pi by 2, excluding those two values, because y is equal to pi by 2 and y is equal to minus pi by 2 are asymptotes. Asymptotes are those lines which meets the graph at infinity, right? However, if you look at the graph, if I draw a line parallel to x-axis, that line meets the graph at only one point. Therefore, it is 1, 1 and not many 1. Anybody can say it is an odd function, right? The reason is it is antisymmetric, right? So, it is an odd function. Tan inverse of minus x is equal to minus tan inverse of x. Very, very important information, right? And observe carefully, dear students, it is passing through origin. Tan inverse of 0 is 0. Understood this, dear students? These are the few of the features of tan inverse function or inverse tangent function. I hope, dear students, you are understanding this and you are enjoying this class. Now let us go to next two graphs, that is integral part of x and fractional part of x. Before that, you please make a note of this. Now we shall talk about greatest integer function. Dear students, this is one of the very, very important part for your JEE mathematics. Anyway, let us draw the graph of greatest integer function and analyze. Look at this. If x lies between 0 and 1, integral part of x, our greatest integer function, is 0. If it lies between 1 and 2, it is 1. Between 2 and 3, it is 2. Between 3 and 4, it is 3. This is 1, this is 2, this is 3. Between minus 1 and 0, it is minus 1. Between minus 2 and minus 1, right? Between minus 2 and minus 1, it is minus 2, and it continues like this. This is the graph of greatest integer function, right? No doubt, it is not continuous, right? it is discontinuous. Anybody can say this by just looking at the graph. Continuous, discontinuous. Where exactly the function is discontinuous? Wherever you are getting an integer, the function is discontinuous. Discontinuous at x belongs to set. Is it correct? Definitely it is not differentiable at x belongs to set. What about the domain of this, dear students? You can give any value for x. Integral part of x exists. Therefore, x belongs to set of real numbers. What is range? You can see vertically, dear students, you have only selected lines like this. They are all existing only at the integral values. That means to say range is y belongs to z, right? So that means to say the values of y is only integer. Understanding this, right? So always, dear students, this is no doubt not at all 1 1. It should be many 1, right? And it is not even odd. It is neither even nor odd because it is neither symmetrical nor anti-symmetric about x-axis or y-axis. Anyway, coming back to this, right? If we draw this line, if I continue this line, then what happens is, this is line is y is equal to x. What about this line, dear students? This is y is equal to x minus 1. Do you agree with me? That is, this is y is equal to x minus 1. This is x minus 1. So, x minus 1 is always less than y, less than or equal to x minus 1 is less than y, less than or equal to x. That is, integral part of x is less than or equal to x. Is that correct? And definitely greater than x minus 1. That is evident from the graph, right? And of course, it is non-periodic. It is non-periodic. Understanding this, dear students, this is integral part of x or greatest integer function. The function greatest integer function can either be positive or be negative. It depends on the value of x. If x is negative, definitely integral part of x is also negative. If x is positive, integral part of x is positive, except when x lies between 0 and 1, where integral part of x is clearly 0. Right? Dear students, please make a note of this. Now we shall go to next one, that is fractional part of x.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.